This is the Trilogy 906 phono stage. Its purpose is to amplify the signal of your cartridge to line level. This amplification is known as gain. The designer has many options on how to achieve the gain that is needed. One option is to use an op-amp. This op-amp has two circuits. Both will need to be used for one channel. This means that your signal will pass through around 60 transistors before it reaches the outside world. Op-amps have a lot of gain. This one is typically 100,000 times. In total, that's around 200 times more gain than we need. So we need to apply negative feedback to reduce the gain. A proportion of the output is fed back to the input. This has consequences for the distortion characteristic of the circuit. Unlike a lot of its competition, the 906 uses discrete semiconductors to achieve gain. Because we are not tied to the constraints of the op-amp, we can design the circuit however we wish. For each channel of the 906, we use 12 individual transistors and one JFET, a lot less active devices than the op-amp solution. We can now optimize the circuit for its given gain. We can also bias it into Class A without negative feedback, and tailor its distortion characteristic to be as low and benign as possible, all of which improve its audio performance. So why don't other manufacturers do this? It requires skill, and it's expensive. It is 10 times more costly to use discrete semiconductors than op-amps, which means less profit for us. But we think it's worth it. And once you hear the 906, we are sure you'll agree.